Okay everyone, welcome back again. This is the third in my little video series on basic chemistry that you need to be successful in almost said organic chemistry course, in our biochemistry course. And this video is on the formation of phosphoesters, which are very, very important compounds in nucleic acid biochemistry for one. And so this is a reaction that you need to know. It proceeds in general similarly to the formation of carboxylic acid esters, but here the site that's going to be attacked by the nucleophilic attack by this alcohol oxygen is not a carbon atom, it's in this case a phosphorus atom. Now if you think about the periodic chart, or you look at the periodic chart, phosphorus is below nitrogen, okay? And so it can actually form 5 different bonds, as you see here, 1, 2, 3, 4, 5. And what's also interesting or important about phosphorus is that phosphorus is down and to the left in the periodic chart from oxygen. And that's a kind of a rule of thumb on the periodic chart. The further down and the further left it gets, the less electronegative it is. So oxygen in this case is much more electronegative than the phosphorus, and so we have the same deal here on the phosphorus atom as we had on the carbon atoms. That phosphorus is slightly negative, slightly positive, and so. And by virtue of the electronegativity of the hydroxyl group on the alcohol, we can get another nucleophilic attack here, this time by the alcoholic oxygen to the phosphate. Now, phosphate can form 5 bonds, but it can't form 6, and so we're going to have to do the same thing that we did with the ester formation from carboxylic acids. We're going to have to move one of these pairs of electrons into a non-bonded pair. And that's going to give us this intermediate here. I'm just going to shortcut some of these OH groups, make it a little bit faster to draw. And we're going to have this structure here, fully analogous to that structure we had with our esterification from carboxylic acid. And then we're going to have this new bond that's been formed here between the, whoops, I actually did that wrong, between the alcohol. We're still going to have that hydrogen there on the alcohol, and that's going to be positively charged. And so what you can see here is this structure here is actually in a triangle with a couple more bonds in here. So this is an intermediate in the addition of the alcohol to the phosphate group, which is that phosphoric acid group. Okay, so just like we had before, we have an extra proton here, and that proton, we can take it and we can actually deprotonate this and add it to another one of these hydroxyl groups here, and protonate that hydroxyl group, and that'll give us another intermediate. So quickly draw these out. We have the same structure here on that oxygen, and now we have a protonated hydroxyl group here. So this is positively charged. We have our neutralized part of the molecule from the alcohol, and we have one additional hydroxyl group over here. And now you can see what's going to happen, right? We're going to be able to actually eliminate water, again, taking that whole bond there, and then we're going to drop one of these bonds back into here. And what that actually gives us then is the phosphoester. Okay, and that finally is going to look like this. P, we get that double bonded oxygen back. Okay, that one hydroxyl group that was originally here has been eliminated as the water over here, and so we've got this OR group still attached. That's our ester part, and we have one additional hydroxyl group corresponding to this one here. Okay, so in order to make this complete, again, it's a condensation reaction, so we generated water that actually came from there. Now this is a hugely important reaction. It's required for all, every nucleotide you ever looked at, for ATP and so forth and so on. This is also fully reversible. We have the ability to back this reaction up. We can hydrolyze these phosphoesters with a nucleophilic attack of the water on the phosphate. That regenerates this intermediate here. We can then transfer that proton over to the alcoholic group, and then we can eliminate the alcohol and regenerate our phosphoric acid and our alcohol. And now we could have also started out here with some other phosphoester. We could have started out with an R group here, okay? And then these R groups would have carried all the way through. I'm going to make a mess out of this, but these R groups could have carried all the way through, and what we would then have is a phosphodiester, okay? And so that's also very important, as we'll see as we go along in the biochemistry course. Phosphoesters and phosphodiesters, very important part of the biochemistry. All right, thanks again for tuning in to this video. I hope these things are helping you out.